October 17, 1942. Naples, Italy. Colonello Giuseppe Martinelli stood in the central operations room of the Italian State Railways Ministry, reviewing the latest intelligence briefing from Axis observers in North Africa. His assistant, Capitano Luca Bernardi, handed him a decoded transmission that had arrived during the night from German intelligence headquarters in Tripoli. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. The Americans are deploying unusually large freight trains, Martinelli read aloud, his voice dripping with skepticism. Reports suggest individual trains pulling between 150 and 200 freight cars. Estimated cargo capacity exceeds 15,000 tons per train. He set the document down on his mahogany desk with visible contempt, letting out a dismissive laugh that echoed through the marble-floored office. Pure fantasy. American propaganda to intimidate our forces. No railway system in the world can pull 200 cars. Our finest locomotives struggle with 40 cars on flat terrain. The physics simply don't allow it. What Martinelli did not know, what none of the Italian Railway Command could comprehend, was that at that very moment, 4,000 miles away in the Nevada desert, Master Sergeant William H. Patterson was supervising the assembly of a 217-car freight train loaded with tanks, artillery, ammunition, and supplies bound for the Port of Oakland, destined for the North African theater. His Union Pacific big boy locomotive, weighing 600 tons and generating 6,290 horsepower, could pull loads that Italian engineers considered mathematically impossible. The arithmetic of logistics was about to be rewritten by a railway system so vast, so mechanized, and so efficient that European minds trained in conventional railway doctrine could not grasp its scale. The Italian confidence in October 1942 was not mere ignorance. It was based on what appeared to be engineering certainty backed by decades of European railway expertise. The Italian State Railways, established in 1905, had built one of Europe's most sophisticated rail networks. Their engineers had studied under the finest technical minds in Germany, France, and Switzerland. Italian locomotives represented the pinnacle of European design philosophy, which emphasized efficiency, mechanical elegance, and practical operational limits. The typical Italian freight locomotive, the FS Class 740, could pull approximately 35 to 40 loaded freight cars on level terrain under optimal conditions. On the mountainous terrain that characterized much of Italy, that number dropped to 25 cars or fewer. These were not limitations of Italian engineering incompetence, but rather acknowledgments of physical reality. Track stress, coupler strength, braking capability, and locomotive power all imposed natural limits that no amount of ambition could overcome. Or so Italian engineers believed. Colonello Martinelli had personally overseen railway operations during the Italian invasion of Ethiopia in 1935 and the campaigns in the Balkans. His experience had taught him that logistics determined battlefield outcomes more reliably than tactical brilliance. He understood railways intimately, their capabilities and crucially, their limitations. A 40-car freight train represented the practical maximum for sustained operations. Anything larger created maintenance nightmares, required excessive track reinforcement, and exceeded the pulling capacity of available locomotives. The German railway advisors attached to Italian headquarters shared this assessment. Oberst Friedrich Kaufmann, a veteran of Deutsche Reichsbahn operations, had briefed Italian command on railway capabilities during the planning for North African operations. His analysis was unequivocal. American railways are extensive but primitive. They operate across vast distances with minimal infrastructure. Their locomotives are powerful but crude, lacking the mechanical sophistication of German or Italian designs. Reports of 200-car trains are clearly exaggerated, likely referring to multiple trains counted as one, or perhaps including empty cars that add no meaningful cargo capacity. The Italian dismissal of American railway capabilities stemmed from both technical doctrine and practical observation. European railways operated in a landscape of dense populations, limited distances, and highly developed infrastructure. Trains ran frequently, carried moderate loads, and operated within carefully calculated engineering parameters. The concept of a single train hauling 200 loaded cars seemed to violate every principle of railway physics. Track stress alone should make such operations impossible. The weight of 200 loaded freight cars would exceed 20,000 tons, far beyond what conventional rail could support without catastrophic failure. Capitano Bernardi, who had studied railway engineering at the University of Bologna, performed calculations demonstrating the impossibility of American claims. Even assuming their locomotives could generate sufficient pulling power, which is doubtful, the coupler mechanisms would fail under such stress. Our couplers are rated for maximum loads of 800 tons. 200 cars would generate forces exceeding 3,000 tons. The couplers would shatter like glass. The intelligence reports from North Africa seemed to confirm Italian skepticism. Early encounters with American supply operations showed nothing unusual. American trucks delivered supplies to forward positions. American ships unloaded cargo at ports. Everything appeared consistent with conventional logistics doctrine. There were no mysterious super trains revolutionizing warfare. The reports of 200 car trains were clearly propaganda, designed to demoralize Axis forces by suggesting unlimited American industrial capacity. Italian military doctrine emphasized mobility and aggressive offensive action. Supply considerations were important but secondary to tactical brilliance and operational speed. The Italian campaigns in North Africa had succeeded through bold maneuver and exploitation of British weaknesses, not through logistics superiority. When supply difficulties arose, as they frequently did, Italian forces adapted through requisitioning local resources and accepting reduced operational tempo. What Italian planners failed to grasp was that American military doctrine represented a fundamental philosophical departure from European warfare. While European armies viewed logistics as a constraint to be minimized through tactical skill, American planners viewed logistics as a weapon to be maximized through industrial capacity. The United States was not trying to fight efficiently within resource constraints. America was attempting to overwhelm opposition through such massive material superiority that tactical skill became irrelevant. But in October 1942, as Colonello Martinelli filed away the intelligence report about impossible American trains, this reality remained invisible to Italian eyes. The numbers seemed too absurd to be credible. 200 cars per train. 15,000 tons of cargo. Locomotives weighing 600 tons. These figures existed outside the realm of Italian railway experience, and therefore outside the realm of Italian belief. The Mediterranean Railway Conference held in Rome during November 1942 addressed Allied logistics capabilities. Senior Italian, German, and Romanian railway officials assessed the transportation challenge facing Axis forces in North Africa. The consensus was clear. Allied supply lines stretched thousands of miles from American industrial centers to North African battlefields. These extended supply lines represented a critical vulnerability. Submarine warfare and air interdiction could disrupt Allied logistics far more effectively than attempting to match their production capacity. No discussion addressed the possibility that American railways might operate on a scale that rendered European calculations obsolete. Part 2. The American Railway Revolution that Italian engineers dismissed as propaganda had roots extending back to the 1860s, when the Transcontinental Railroad first connected the vast distances of the North American continent. Unlike European railways that developed in densely populated regions with short distances between major cities, American railroads were built to conquer geography itself. The distances were not hundreds of kilometers but thousands of miles. The terrain was not manicured countryside but untamed wilderness ranging from desert wasteland to mountain ranges that dwarfed the Alps. American railway engineering developed in response to these unique challenges, creating solutions that European designers never needed to consider. The Union Pacific Railroad, established during the Civil War, pioneered heavy freight operations across the American West. By 1942, their fleet included the largest, most powerful locomotives ever constructed. The Big Boy class, designed specifically for heavy freight operations over Wyoming's Sherman Hill, represented engineering philosophy that Italian designers would have considered reckless. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel, it means a lot to us. Now back to the story. Each locomotive weighed 600 tons, stretched 132 feet in length, and generated power outputs that exceeded entire Italian locomotive depots. The boiler alone weighed 465,000 pounds and operated at pressures that would have terrified European safety inspectors. But raw power alone did not explain American railway superiority. The entire system had evolved to handle massive freight loads. American rail was heavier, laid on deeper roadbeds with more substantial ballast. Couplers were not the delicate mechanisms of European design but massive cast steel assemblies capable of handling forces exceeding 5,000 tons. Braking systems incorporated continuous air brake lines running the entire length of trains, allowing synchronized braking across 200 cars simultaneously. Track switches were built to handle weights that would have crushed Italian infrastructure. American freight cars themselves differed fundamentally from European designs. Where Italian cars averaged 15 to 20 tons capacity, American freight cars routinely carried 50 to 70 tons. The cars were larger, built with heavier steel, and designed for rough handling across thousands of miles. A single American freight car could carry more cargo than 3 Italian cars, and American trains pulled 10 times as many cars. The mathematical implications were staggering, but remained invisible to observers trained in European railway doctrine. Lieutenant Colonel James Mitchell, commanding the 756th Railway Operating Battalion, understood that American railway superiority represented more than just bigger equipment. The entire operational philosophy differed from European practice. European railways emphasized frequent service with moderate loads. American railways emphasized massive loads with less frequent service. A European railway might run 10 trains per day carrying 40 cars each. An American railway would run 2 trains per day carrying 200 cars each. The total cargo capacity was identical, but the operational efficiency was vastly different. Fewer trains meant fewer crews, less fuel consumption, reduced track congestion, and more flexible scheduling. The 756th Railway Operating Battalion deployed to North Africa in November 1942 as part of Operation Torch, the Allied invasion of French North Africa. Their mission was to establish and operate military railways supporting the invasion force. Mitchell brought with him not just American railway equipment but American railway doctrine. His battalion would operate trains the American way, which meant trains that Italian observers would consider impossible. The first challenge was infrastructure. North African railways had been built by the French to European standards, designed for light to moderate freight operations. The track was lighter than American standard, the bridges were rated for lower weights, and the entire system operated on assumptions of European-scale operations. Mitchell's engineers spent the first month conducting surveys and reinforcements. Critical bridges received additional support structures. Mainline track was inspected and reinforced with American rail where necessary. Switching yards were expanded to handle longer trains. Water towers were upgraded to service the massive American locomotives that consumed water at rates exceeding European designs by factors of 3 or 4. By January 1943, the 756th was ready to demonstrate American railway capability. The first test run departed from Casablanca on January 8, 1943. Locomotive 4019, a Union Pacific Challenger class engine, pulled 187 freight cars loaded with ammunition, rations, fuel, and spare parts. The train stretched nearly 2 miles in length and carried 11,400 tons of cargo, more than Italian railways moved in an entire week of operations to their North African forces. The journey to the forward supply depot at Tebessa covered 847 miles and required 38 hours of continuous operation. French railway workers who witnessed the train's passage were stunned into disbelief. Nothing in their experience prepared them for the sight of a single train longer than many entire villages, pulled by a locomotive that seemed to violate every principle of railway physics they had learned. Word of the massive American trains spread quickly through North African railway communities, but Italian intelligence dismissed the reports as exaggerated accounts from unreliable sources. Colonello Martinelli, reviewing reports of American railway operations in February 1943, remained skeptical. The numbers were too absurd. A single train carrying more cargo than a week of Italian operations? Impossible. The reports must be counting multiple trains or including empty cars to inflate the numbers. What Martinelli could not grasp was that American industrial capacity operated on a scale that rendered European comparisons meaningless. The United States was not trying to match Italian railway efficiency. America was attempting to bury opposition under avalanches of material so massive that resistance became futile. A single American train could deliver enough ammunition to sustain an entire Italian division for a month. And America was running dozens of such trains every week. The mathematics were becoming undeniable to those willing to see, but Italian command remained blind to the reality unfolding across North Africa. Part 3. March 1943 brought the first systematic demonstration of American railway superiority that even the most skeptical observers could not dismiss. The Battle of El Guetter required massive ammunition resupply for American artillery units engaging German and Italian forces. Lieutenant Colonel Mitchell received orders to deliver 8,000 tons of artillery shells to forward positions within 72 hours. Using European railway doctrine, this would require dozens of trains operating continuously. Mitchell dispatched 4 trains. Each train consisted of between 180 and 210 freight cars, pulled by single locomotives operating in conditions that Italian engineers would have declared impossible. The trains navigated mountain grades, crossed bridges built for traffic 1/3 their weight, and delivered their cargo with mechanical precision. Italian prisoners captured during the El Guetter engagement reported seeing American supply trains that stretched beyond the horizon. Their interrogators dismissed these accounts as the confused observations of demoralized troops. Surely they had seen multiple trains and mistaken them for single consists. No alternative explanation seemed credible to minds trained in European railway limitations. But the evidence was accumulating beyond the point where dismissal remained tenable. German intelligence officers, more systematic in their analysis than their Italian counterparts, began documenting American railway operations with growing alarm. Oberst Kaufmann, the German railway advisor, submitted a classified report to both German and Italian high commands in April 1943 that should have shattered comfortable assumptions. His report included photographs captured from reconnaissance aircraft showing American trains that were undeniably real and undeniably massive. The photographs showed trains stretching across desert landscape for distances exceeding 2 kilometers. Individual freight cars could be counted in the images. The numbers ranged from 160 to 220 cars per train. Kaufmann's report included engineering analysis calculating the cargo capacity of these trains. His conclusions were stark and undeniable. American railway operations in North Africa exceed European capabilities by factors of 5 to 1 in cargo capacity per train. Their locomotives generate power outputs we considered theoretically possible but practically unattainable. Most critically, they have solved the engineering challenges of ultra-long train operations that we believed insurmountable. The Italian response to Kaufmann's report revealed the depth of institutional resistance to acknowledging American superiority. Colonello Martinelli, now facing photographic evidence that contradicted his earlier dismissals, shifted his argument rather than admitting error. The Americans can perhaps operate such trains in the flat desert terrain of North Africa, but these methods would fail completely in European conditions. Our mountainous terrain, our tighter curves, our older infrastructure would make such operations impossible. These are special-purpose trains for unique conditions, not evidence of general railway superiority. This rationalization ignored the obvious reality that American trains were operating in North Africa precisely because American logistics could deliver overwhelming material superiority to any battlefield. The specific terrain was irrelevant. What mattered was that American railways could deliver 5 times the cargo with the same number of trains, using the same amount of fuel, with the same size crews. The efficiency multiplier was devastating to opponents who could not match such capacity. May 1943 brought the Allied victory in Tunisia and the surrender of 275,000 Axis troops, the largest surrender of the war to that point. Italian and German prisoners were marched past American supply dumps that contained material stockpiles beyond anything in their experience. Mountains of ammunition crates, warehouses filled with rations, vehicle parks containing thousands of trucks and tanks, all delivered by railway operations that Italian logistics officers had declared impossible 6 months earlier. Tenente Carlo Rossini, an Italian railway officer captured at Tunis, was interrogated by American intelligence officers curious about Axis logistics capabilities. During the interrogation, Rossini mentioned his disbelief at American supply abundance. His interrogator, Captain Robert Stedman, took Rossini on a tour of nearby railway operations. Rossini watched in stunned silence as a 203-car freight train departed for forward positions, its single locomotive pulling a load that would require 7 Italian trains to match. "This is routine for us," Stedman explained. "We operate trains like this across the entire United States, every single day. This is not special equipment for military operations. This is simply how American railways function." The psychological impact of this revelation on Italian prisoners extended beyond simple logistics appreciation. They began to understand that they had been fighting an opponent whose industrial capacity operated on a scale they could not comprehend. The massive trains were not examples of American ingenuity or battlefield improvisation. They were the routine, everyday operations of a railway system built over decades to handle continental-scale commerce. America was applying its peacetime logistics capacity to warfare, and the result was material superiority that rendered Italian industrial efforts meaningless. June brought the planning for the invasion of Sicily, and American railway operations shifted to supporting the largest amphibious operation attempted to that point in the war. The 756th Railway Operating Battalion and newly arrived sister units began moving invasion supplies to North African ports. The scale of operations increased beyond anything previously attempted. Trains carrying 200-plus cars became routine. Some special operations trains exceeded 250 cars, pushing the absolute limits of locomotive capability and track capacity. Italian intelligence monitoring Allied preparations for Sicily could no longer deny the reality of American railway superiority. Reports flooding into Rome from multiple sources all confirmed the same impossible truth. The Americans were operating trains that exceeded Italian capabilities by factors that made competition futile. A single American train could deliver more material than Italian railways could move in a week of maximum operations. The industrial gap was not merely substantial, it was civilizational. Italy was fighting a nation whose routine logistics operations exceeded Italian maximum efforts by orders of magnitude. Colonello Martinelli, reviewing the accumulated evidence in June 1943, finally acknowledged what he should have understood 9 months earlier. The intelligence reports had been accurate. The Americans had indeed deployed trains pulling 200 cars. His dismissal had been based on European assumptions that simply did not apply to American engineering philosophy. "We calculated what was possible within our framework," he wrote in his final report to the Italian High Command, "and assumed those limits were universal. We were wrong. The Americans built their railways to conquer a continent. We built ours to connect cities. The difference in scale makes their logistics capacity fundamentally superior to ours." Part 4. July 1943 brought the Allied invasion of Sicily, and with it the most comprehensive demonstration of American railway logistics superiority that Italian forces would ever witness. The invasion required moving 180,000 troops, 600 tanks, 1,800 artillery pieces, and supplies sufficient to sustain operations for 30 days. American railways delivered this staggering quantity of material to North African ports in just 19 days of intensive operations. Lieutenant Colonel Mitchell's 756th Railway Operating Battalion, now reinforced by the 713th and 729th Railway Operating Battalions, ran trains continuously around the clock. Each battalion operated an average of 6 trains per day, with each train carrying between 190 and 230 freight cars. The mathematical result was cargo delivery capacity exceeding 85,000 tons per day, more than the entire Italian railway system could move across their entire national network. Italian defenders on Sicily watched the invasion unfold with growing comprehension of just how thoroughly they had underestimated American industrial capacity. The beaches were not simply supplied, they were buried under avalanches of material that arrived faster than combat units could consume it. Supply dumps grew larger by the hour as American trains continued delivering cargo that exceeded battlefield consumption rates. General Castelli, now working as a technical advisor to American forces, reviewed the annual statistics with a sense of professional humility that bordered on despair. "We built beautiful railways," he observed to Lieutenant Colonel Mitchell during a planning meeting for 1944 operations. "Elegant stations, sophisticated signaling systems, locomotives that were mechanical works of art. And we moved approximately 1/15 the cargo per train that your railways handle routinely. We optimized for elegance. You optimized for capacity. In warfare, capacity is what matters." The lesson was spreading through Italian industrial and military circles. American superiority was not a matter of temporary advantage or battlefield luck. It was systematic industrial capacity operating on scales that Italian manufacturing could not approach. The 200-car trains that had seemed impossible in October 1942 were now routine operations that Italian railway workers witnessed daily. The mathematics of industrial warfare had been rewritten, and Italy had been on the wrong side of the equation from the beginning. January 1944 brought the strategic revelation that transformed Italian understanding of why they had lost the war before the first shot was fired. American railway operations were not wartime innovations or special military developments. They were simply the peacetime commercial operations of a nation built on continental-scale logistics. Master Sergeant William Patterson, the same railway supervisor who had assembled that 217-car train in Nevada back in October 1942, was now in Italy training Italian railway workers on American operational procedures. During one training session at the Naples railway yards, an Italian engineer named Giuseppe Caruso asked the question that had haunted Italian railway professionals since Sicily fell. When did America develop these massive trains for the war? What special military program created locomotives powerful enough to pull 200 cars? Patterson looked genuinely confused by the question, then laughed with the unself-conscious amusement of someone who had never considered an alternative. Develop for the war? These are the same trains we've been running since the 1930s. The big boy locomotives were designed in 1941, but Challenger-class engines have been pulling 180-car freight trains across Wyoming since 1936. This isn't military equipment. This is how we move commercial freight across America every single day. The silence that followed Patterson's explanation was profound and devastating. The Italian engineers in the room were confronting a reality they had refused to acknowledge for 2 years. America had not mobilized special capabilities for warfare. America had simply applied its routine peacetime logistics to military purposes, and that routine capacity exceeded Italy's maximum wartime efforts by factors of 10 to 1. Caruso, who had studied railway engineering at Milan Polytechnic and worked for Italian state railways for 20 years, felt the foundations of his professional understanding crumbling. "You mean American farmers and merchants ship their goods on trains carrying 15,000 tons of cargo? This is normal for you?" Patterson nodded as if the question was absurd. "Sure. How else would you move grain from Kansas to New York? Or cattle from Texas to Chicago? Or coal from Wyoming to California? America is 3,000 miles wide. You can't operate a continental economy with small trains making frequent runs. You need massive capacity or nothing moves efficiently." The conceptual gap was finally, brutally clear. Italy had built railways to connect cities in a nation 700 miles long. America had built railways to connect oceans across a continent 3,000 miles wide. The scale difference was not a military advantage. It was civilizational infrastructure that existed long before warfare began. February brought the statistical analysis that Italian industrial planners had been avoiding. At the request of the nascent Italian co-belligerent government now allied with America against Germany, American logistics officers provided comprehensive data on railway operations. The numbers were compiled into a report that circulated through what remained of Italian industrial ministries like a death certificate for Italian industrial ambitions. Peak American railway operations in Italy, December 1943, 127,000 tons of cargo moved in a single day using 43 trains. Average cargo per train, 2,953 tons. Peak Italian railway operations, entire national network, July 1940, 4,800 tons of cargo moved in a single day using 126 trains. Average cargo per train, 38 tons. The Americans were moving in one day what Italy had moved in a month. Each American train carried what 78 Italian trains carried. And this was not America's maximum capacity, merely what they chose to deploy to a secondary theater while simultaneously conducting operations across the Pacific, supplying Britain and the Soviet Union, and maintaining their domestic economy. Colonello Martinelli, reading these statistics in his temporary office in Naples, finally understood the full scope of his October 1942 dismissal. He had not simply been wrong about American trains. He had been wrong about the fundamental nature of industrial warfare. "We were fighting arithmetic," he wrote in his personal journal, an entry preserved in Italian military archives. "We thought warfare was about courage, tactical skill, and operational brilliance. The Americans understood it was about multiplication. One American train equals 78 Italian trains. One American locomotive equals 5 Italian locomotives. One American railway battalion moves more cargo than our entire national railway system. These are not military advantages. These are mathematical certainties that made our defeat inevitable from the moment we chose to fight." March 1944 brought the complete integration of Italian railway workers into American logistics operations. Italian engineers and crew members who had operated 40-car trains now found themselves manning operations moving 200-car consists. The transition was psychologically difficult but technically straightforward. The principles of railway operations remained unchanged. Only the scale had expanded beyond what Italian doctrine had considered possible. Tenente Rossini, the Italian railway officer who had been captured in Tunisia and later joined the co-belligerent forces, commanded an Italian crew operating American equipment on the main supply line to the Gustav Line front. His train on March 15 consisted of 214 freight cars carrying 13,100 tons of ammunition and supplies. He completed the 340-mile journey in 29 hours, delivering more cargo in a single trip than his entire pre-war battalion had moved in a typical month of operations. "I thought I understood railways," Rossini reflected in a letter to his family preserved in Italian war archives. "I had studied engineering, operated trains for 12 years, commanded railway units in Africa and Italy. Then I operated an American train and realized I had been playing with toys. This is industrial capacity on a scale I never imagined possible. We were not defeated by better soldiers or superior tactics. We were buried under logistical capacity so vast that resistance was mathematically futile." April brought the breakthrough at the Gustav Line, enabled partly by American railway logistics that delivered ammunition at rates exceeding Italian defensive consumption by factors of 20 to 1. American artillery batteries could fire preparatory barges consuming more shells in an hour than Italian forces received in a week because American railways could deliver replacement ammunition faster than guns could fire it. The railway capacity difference had translated into firepower superiority that rendered Italian defensive positions untenable regardless of fortification strength or defender courage. May 1944 brought the final accounting of American railway superiority that would influence military doctrine for generations. The 756th Railway Operating Battalion alone had moved 1.2 million tons of cargo during its 18 months in the Mediterranean theater. This exceeded the total cargo moved by the entire Italian railway system during any comparable pre-war period. A single American railway battalion had outperformed an entire national railway network. The strategic implications extended far beyond World War II to reshape understanding of how industrial capacity determined warfare outcomes. General Castelli, now serving as senior Italian liaison to American Logistics Command, authored a comprehensive analysis of railway operations that became required reading at Italian and later NATO military academies. His conclusions were stark and unambiguous. Modern warfare is decided by logistics capacity long before battles begin. The side that can deliver 5 times the supplies, 10 times the ammunition, and 20 times the replacement equipment will win regardless of tactical skill. American railway capacity was not a military advantage. It was an industrial reality that made Axis defeat inevitable. We calculated victory chances based on soldier quality and tactical doctrine. We should have calculated based on tons of cargo deliverable per day. Those calculations would have shown we were attempting the impossible. June brought the liberation of Rome and the systematic expansion of American railway operations throughout central Italy. The trains grew even larger as American engineers gained confidence operating in Italian terrain. Some special logistics trains exceeded 240 cars, pushing absolute limits of locomotive capability. Italian railway workers who witnessed these operations understood they were seeing the future of industrial logistics, a future where their elegant pre-war systems would be remembered as quaint relics of a smaller age. The human cost of Italian railway limitations extended beyond military defeat to economic consequences that would shape post-war recovery. Italian industrial capacity had been optimized for a European-scale economy, and suddenly that scale seemed hopelessly inadequate. The psychological impact on Italian engineering pride proved difficult to overcome. Professionals who had considered themselves world-class railway experts now understood they had been operating at scales comparable to American regional branch lines. July 1944 brought American operations in France following the Normandy invasion, and with them the final demonstration of how railway capacity determined campaign outcomes. American railways delivered supplies to French ports at rates that exceeded German defensive consumption by factors exceeding 30 to 1. German forces fought brilliantly but drowned under avalanches of American material delivered by railway operations that German logistics could not approach. The lesson that Italy had learned painfully in 1943 was being repeated across Europe with the same inevitable results. Industrial capacity determined strategic outcomes regardless of tactical skill. August brought the liberation of Florence and systematic American railway operations extending into northern Italy. Colonello Martinelli, traveling with American logistics units, witnessed operations in terrain he had insisted would make American methods impossible. American engineers had re-engineered mountain rail lines, reinforced bridges, and upgraded infrastructure to handle 200 car trains through landscape Italian doctrine considered unsuitable for trains half that size. I was not wrong about physics, Martinelli explained to General Castelli during a planning conference. I was wrong about ambition. Italian engineers calculated what was possible within our constraints and stopped there. American engineers calculated what was necessary to achieve their goals and then re-engineered constraints to make it possible. We accepted limitations. They eliminated limitations. That philosophical difference determined everything. September 1944 brought the statistical summary that would define post-war understanding of railway logistics. American railway operations in the Mediterranean and European theaters had moved 47 million tons of cargo during 1944. This exceeded the total cargo moved by all Axis railways combined during the entire war. The scale of American logistics superiority was so vast that comparison became meaningless. America had not competed with Axis logistics. America had operated in a different category entirely. The final irony of the Italian railway story emerged in post-war reconstruction. The Marshall Plan brought American financial assistance to rebuild Italian infrastructure, and American advisors recommended upgrading Italian railways to handle heavier freight loads. Italian engineers, humbled by wartime experience, embraced American operational philosophy. Post-war Italian railways were rebuilt with heavier track, more powerful locomotives, and infrastructure designed for continental-scale operations. By 1955, Italian trains routinely pulled 80 to 100 cars, more than double pre-war capacity. By 1970, Italian railways approached American operational scales, moving cargo at rates that would have seemed impossible to Colonello Martinelli in 1942. The American Revolution in railway logistics had transformed not just military operations but global industrial understanding of what railways could achieve. Modern logistics professionals study the Italian railway experience as the definitive lesson in how industrial capacity determines strategic outcomes. The concentrated capacity of American railways proved more decisive than tactical brilliance, operational skill, or defensive fortifications. Mathematics defeated courage, and industrial scale overwhelmed military sophistication. The railway workers who survived the war carried forward lessons that shaped post-war economic development. Infrastructure investments that seemed excessive by pre-war standards became recognized as necessary foundations for industrial competitiveness. Nations that built railways to Italian pre-war scales found themselves unable to compete economically with nations that adopted American operational philosophy. Up next, you've got two more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out. And don't forget to subscribe and turn on the notification bell so you don't miss any upload from us.